Hello, this is your Professor Sudha, section 3.3 Measures of Position. In this section, you will be learning how to compute and interpret z-scores, how to compute quartiles, percentiles, 5-number summary for a data set, and understand the effects of outliers and how to construct the box plot to visualize the 5-number summary and outliers. Objective 1. Compute and interpret z-score. Who is taller? A man 73 inches tall or a woman 68 inches tall? The obvious answer is that the man is taller because 73 is a number bigger than 68, right? Let me ask the question in a different way. Who is taller relative to their gender? A man 73 inches tall or a woman 68 inches tall? One way to answer this question is with a z-score. The z-score of an individual data value tells us how many standard deviation that value is from its population mean. For example, a value 1 standard deviation above the mean has a z-score of 1. And a value 2 standard deviation below the mean has a z-score of -2. So, if it is above the mean, z-score will be positive number, you can see that. If it is below the mean, z-score will be negative. Let x be a value from a population with mean mu and standard deviation sigma, then z-score of x is x minus mu divided by sigma. Let's look at an example on how to compute and interpret z-score. In this example, the mean height for adult men in US is given with the standard deviation, and the mean height for the adult woman and the standard deviation is given. We need to find who is taller relative to their gender. First, we will compute the z-score for the two heights. For both, we will use the formula x minus mu divided by sigma to find the z-score and use the values from here and substitute. And this is for women. So, we found the z-score for each one. Now, we need to interpret this. The height of 73 inches man is 1.16 standard deviation above the mean height for men. The height of 68 inches woman is 1.50 standard deviation above the mean height for woman. Therefore, woman is taller relative to the population of women than the man is relative to the population of men. Z-score and the empirical rule. Z-score work best for the population whose histograms are approximately bell shape. Empirical rule says that 68% of the data will be within 1 standard deviation from the mean and 95% of the data will be within 2 standard deviation from the mean, and almost all will be within 3 standard deviations from the mean. Since z-score is the number of standard deviation from the mean, we can easily interpret the z-score for bell-shaped populations. So, z-score 2 means that is 2 standard deviation from mean. Objective 2. Compute the quartiles of a data set. Quartiles divide a data set into 4 approximately equal pieces. Every data set has 3 quartiles. The first quartile is denoted by Q1, separates the lowest 25% of the data from the highest 75%. Second quartile denoted by Q2, which divides the entire data into half, so 50%. Q2 is same as the median, and third quartile Q3 separate the lowest 75% of the data from the highest 25%. Procedure for computing quartiles. First, arrange the data in increasing order. Let n be the number of values in the data set. The median will be the second quartile. And if you multiply 0.25 to n, you will get the first quartile. If you multiply 0.75 times n, you will get the third quartile. If L is a whole number, quartile is the average of the number in the position L and the number in the position L plus 1. If L is not a whole number, round it up to get the next higher whole number. The quartile is the number in the position corresponding to the rounded up value. We will look an example so that it will be easier to understand this. This table represents the annual rainfall in inches in Los Angeles during the month of February from 1969 to 2013. We need to compute the quartiles for the data. So, first step is arrange the data in increasing order. So, if you look at that, it is already arranged in increasing order. There are 45 values in the data set. So, n will be equal 45. First, we will find the first quartile. So, find L by multiplying n by 0.25. That is not a whole number, so round up. So, Q1 is the number in the position 12. So, 0.92. Second quartile is the median. Since there are 45 values here, median will be the number in the 23rd position. So, that number is 3.12. Third quartile, the procedure is almost same as finding the first quartile, but instead of multiplying by 0.25, we will multiply by 0.75. L is 33.7F, which is not a whole number, so round up and find the number in the 34th position, which is 4.94. So, Q3 is 4.94. These are the three quartiles. Let us make a dot plot for this data, and this represents the dot plot for the data, and this is the first quartile, this is the second quartile, and this is the third quartile. These three quartiles divide the entire data into 4 parts, 1, 2, 3, 4, and each part will have 25% of the data. This is the smallest value of the data and this is the largest value of the data. Second quartile will be the median. The quartiles divide the data set into 4 parts only. Sometimes it will be useful to divide a data set into a greater number of pieces to get more detailed description of the distribution. So, percentiles provide a way to do this. Percentile divide a data set into hundreds. Procedure for computing percentiles. First, arrange the data in increasing order. If there are n number of values in the data set, first calculate L, P divided by 100 times n. If L is a whole number, find the number in the position L and L plus 1, then take the average of those numbers. If L is not a whole number, round it up and take the number correspond to that. In this example, we need to compute the 60th percentile. So, first arrange this data in order, and the second step is calculate L. Since L is a whole number, find the average of the numbers in 27th and 28th position. So, 60th percentile is 3.64. Computing a percentile from a given data value. First, arrange the data in increasing order. Let x be the data value whose percentile is to be computed. So, we will use this formula and round the result to the nearest whole number. This is the percentile corresponding to the value of x. This table represents the annual rainfall in Los Angeles during February from 1969 to 2013. In 1989, the rainfall was 1.90. What percentile does this correspond to? This is already arranged in increasing order. So, 1.90 is here. So, there are 17 values less than 1.90. In the first row, we have 15 values. So, 15, 16, 17. So, 17 values are less than 1.90. Now use this formula and calculate the percentile and round up that value. The value 1.90 correspond to the 39th percentile. Objective 4. Compute the 5-number summary for a data set. The 5-number summary consists of median, first quartile, third quartile, smallest value, largest value. I always think minimum and maximum value. Then the median is in the middle. Then comes quartile 1 and quartile 3. Remember, median is same as quartile 2. So, these are the 5-number summary. So, smallest value, largest value, middle number, quartile 1, quartile 3. So, 1, 2, 3, 4, 5, 5-number summary. Let us look at an example. Compute the 5-number summary of this data. So, here n is 45. Smallest value of the data is 0.00. Largest value is 13.68. Middle number or median is the data in 23rd position, that is 3.12. We already computed Q1 and Q3 previously, so we can use those values here. Quartile 1, we multiply the n by 0.25 and this is a decimal, so we round that up, that is the 12th position, value in the 12th position. So, 0.92, and quartile 3 we multiply n by 0.75 and round this up. So, value will be the value in the 34th position, 4.94, and median is the middle number. Since there are 45 values in the data, middle number will be at 46 divided by 2, that is 23rd position, that is 3.12. An outlier is a value which is too large or too small compared to the other values in the data set. Some outliers result from errors. If you misplace a decimal, for an example, if you have a data 83.2, we misplace the decimal and we are writing 8.32. This becomes really small. Or instead of 8.32, if you miss the decimal, it will be 832. That is a too big number compared to the actual value. So, when it is certain that outlier is resulted from an error, the value should be corrected or deleted. Do not delete an outlier unless it is certain that this is an error. Deleting an outlier that is not an error will produce misleading results. In this example, we need to find the outliers. These are the temperature readings in Fahrenheit. So, if you look at that, you can see all these are 2 decimal places close to 80 or any values between 75 and 95, I can say, and only this one 8.45, that is too small compared to the other values in the set. So, we can say 8.45 is a outlier. It is likely that the decimal place is misplaced. The outlier should be corrected if possible or deleted. So, outlier is certainly an error. One method for detecting outliers is called the interquartile range. Interquartile range is Q3 minus Q1. Interquartile range method for detecting outliers. First find Q1 and Q3 and find the interquartile range Q3 minus Q1. Compute the outlier boundaries. Those boundaries are the cutoff points for determining the outliers. So, lower boundary will be Q1 minus 1.5 interquartile range and the upper outlier boundary will be Q3 plus 1.5 interquartile range. Any data value that is less than the lower outlier boundary or greater than this value is considered to be an outlier. Let us look at an example. In this example, we need to identify the outliers. So, first arrange the data in order, then find the minimum and maximum and median. First find Q1 and Q3. So, multiply 22 by 0.25. This is a decimal, so round up and find the number in the 6th position. So, Q1 is 45. Q3 multiply 0.75 by 22 and this value is also decimal, so round up and Q3 is the number in the 17th position. So, 59. Now, find the interquartile range. So, Q3 minus Q1 equal 14. Now, find the lower outlier boundary. This is the formula. So, substitute the values for Q1 and IQR. So, lower outlier boundary is 24. Now, find the upper outlier boundary. This is the formula to find the upper outlier boundary, that is 80. Any data value below 24 will be an outlier and any data value greater than 80 will be also an outlier. So, see, is there any data value less than 24? So, there is no data value less than 24. Is there any value greater than 80? There is one, right? Yes, 100. So, 100 is an outlier. A box plot is a graph that represents the 5-number summary along with some additional information about the data, like including outliers. There are several different kinds of box plot. The one we describe here is sometimes called a modified box plot. Let us construct a box plot for the previous example. In the previous example, we found the 5-number summary. This is the minimum, this is the maximum, this is the median, and this is Q1 and this is Q3. Median is also Q2. Lower outlier boundary is 24 and upper outlier boundary is 80. First draw a number line. Smallest value is 41, so I am going to start with 40 and equally spaced I am going to mark 50, 60, 70, 80, 90 and 100. I do not need more than 100 because our maximum is 100. Then I am going to plot these 5 points. So, 41, so it will be here close to 40 but bigger than 40, 45 next number, that will be in the middle of that. So, 45, 51 right side of 50, then 59 will be left side of 60 and 100. So, 100. Now, draw a vertical line at Q1, Q2 and Q3. So, I am going to draw a vertical line here and make a box out of that. Now, find the largest value smaller than the upper boundary. So, upper boundary is 80. So, we need to find a value smaller than this, but in that we need to choose the bigger one. So, 77. And then we find the smallest value greater than the lower boundary. So, lower boundary is 24. We need to find the smallest value greater than that. So, smallest value greater than this. So, smallest value greater than 24 in this list is 41. So, now mark 41 and 77. So, 77 is left side of 80. Then join these using a horizontal line. 100 is outside of the boundary. So, that is an outlier. So, outlier, mark that as X. So, this is the box plot. These three are Q1, Q2, Q3. This is the outlier. This is the largest value smaller than the upper boundary. This is the smallest value greater than the lower boundary. Let us see how can we use the box plot to determine the skewness in the data set. Here the median is closer to the first quartile than the third quartile, or the upper whisker is longer than the lower whisker. Then the data will be skewed to right. If the median is approximately halfway between the first and the third quartile and the two whiskers are approximately equal in length, then the data will be approximately symmetric. If the median is closer to the third quartile than the first quartile and the lower whisker is longer than the upper whisker, then the data will be skewed to the left. In this section, you learn how to compute the z-score and how to interpret the z-score and how to compute the quartiles of the data set, how to compute the percentile and how to compute the percentile corresponding to a given data value and how to find the 5-number summary for a data set and how to determine outliers using IQR method, interquartile range method, and how to construct a box plot and use it to determine the skewness of the data set.